Good morning, students. Today we'll discuss remaining questions of exercise 13.2, limits and derivatives, maths class 11th. So in previous 2-3 videos, we have completed the limits and few questions of differentiation also from exercise 13.2. So we'll move forward. In previous class, I explained how to differentiate a function using first principle, some questions of the product rule, some questions of the quotient rule. Now, up to second part of question 9 we discussed in last class. Now third question we will discuss today. So third part is actually fx is equal to x raised to power minus 3 5 plus 3x. So simply use the product rule. The first function as it is, differentiation of second. Now second as it is, or differentiation of first. So differentiation of 5 plus 3x. Differentiation of 5 is 0. 3x means 3 will take as it is, and differentiation of x is 1. So it will be 3 only. Now 5 plus 3x as it is, differentiation of x raised to power minus 3 is minus 3 into x raised to power minus 4 using the formula of x raised to power n. Okay, now later part you can solve yourself. Now come to the question number 4. So in this question number 4, although over here I've used the product rule, but need not to use product rule. I explain this by some other method, direct method, without using any product rule. You just open the bracket. So fx will be 3x5 minus 6 into x raised to power minus 4. Okay, so just differentiated this 3 as it is, differentiation of x5, that will be 5x4 minus 6 as it is, differentiation of x raised to power minus 4 will be minus 4 into x raised to power minus 5. So differentiation is over. Later part you can solve yourself. You will get this as the answer. Similarly, the next question is there. That is fx is equal to x raised to power minus 4 into 3 into x raised to power minus 4 into 3 minus 4 into x raised to power minus 5. Again, I will do by this method. You can also try this question using the product rule. So solving this question by the same method, just open the bracket. It will be 3 into x raised to power minus 4 minus 4 into it will become x raised to power minus 9. So differentiate this 3 as it is. We'll take it out. We'll differentiate x raised to power minus 4. That will be minus 4 into x raised to power minus 4 minus 1, that is minus 5. Minus 4 as it is. Differentiation of x raised to power minus 9 will be minus 9 as it is. X raised to power minus 9 minus 1, that is minus 10. So differentiation is over. You just calculate this will be minus 12 upon x5, and this will become plus 36 upon x10. That would be the answer. Sixth part, differentiation of 2 upon x plus 1 minus x square upon 3x minus 1. So we'll differentiate this separately and this separately. So both these two parts will differentiate using the quotient rule. It is 2 upon x plus 1, and this is x square upon 3x minus 1. So differentiating 2 upon x plus 1 by quotient rule, x plus 1 is as it is, denominator as it is, differentiation of numerator, minus now numerator 2 is as it is, differentiation of denominator, that is x plus 1, divided by denominator whole square. This is the formula. Derivative of this will be your denominator 3x minus 1 as it is, differentiation of numerator x square, now minus numerator as it is, and differentiation of denominator divided by denominator whole square. Over here, derivative of 2 is 0. We know the differentiation of constant is 0, so it is 0. And derivative of x plus 1 we will calculate. First, differentiation of x is 1, and differentiation of 1 will be 0. So its differentiation is 1 only. So we will have 2 into 1. In this derivative of x square, differentiation of x square is 2 into x raised to power 2 minus 1. So it will come out as 2x only. And differentiation of 3x minus 1 we will calculate. So first 3 as it is, and differentiation of x, that is 1. So the differentiation of 3x will be 3x only. and differentiation of this one is 0. So it will be 3 into x square. Now you just take the LCM and simplify it. Okay, your differentiation part is over. Later part, if you want to try, you can do it, or you can leave it as it is also. If you want to match the answer from backside, then you have to further solve it. Otherwise, you can leave it as it is. Question number 10. Find the derivative of cos x using the first principle. So using the first principle, we will differentiate cos x. We know that formula for differentiation, as we have already done these things. Formula for differentiation using first principle is f dash x is equal to fx plus h minus fx divided by h. This is the formula for differentiation using first principle. Now fx plus h we will calculate from this, as fx is given cos x. So in this both side replace x by x plus h. You will get it is cos x plus h. Minus fx means minus cos x divided by h. Alright. So in this it is done by some method. I am explaining you the entirely different method. You apply formula of sin c cos c minus cos d. This is cos c minus cos d. That would be equal to minus 2 sin c plus d by 2 c plus d x plus h plus x means 2x plus h by 2, that will become x plus h by 2 into sin c minus d by 2, that will be sin h by 2 divided by h. We know that limits s tends to 0, sin h by 2 upon h by 2 will become 1. So I will multiply this part by 2 and divide this part by 2. So this is 1. And this 2 is cancelled out with this 2. 2 is cancelled out with this 2. So we are left with minus sin of x plus h by 2 limit s tends to 0. So put h equal to 0 in this. You will have minus sin x as the answer. So as simple as this. What you have to do, you have to apply formulas cos x plus h minus cos x. That will be minus 2 sin c plus d by 2 sin c minus d by 2. We'll get this term. In this particular term, in denominator h is already there in this formula. So we know that h tends to 0. If it is sin h by 2, we must have h by 2 in the denominator. So I have divided this by 2 and multiplied this by 2. This 2 cancel out this 2. And we are left with this much only, and put limit s tends to 0, you will get your answer. Now find the derivative of the following functions, question number 11. So these all are the formulas, we will do them. First one, sin x into cos x from first principle. Sin x into cos x, you have to differentiate. Find the derivative of following functions. Actually, it is not asked using the first principle. But over here, these are done using the first principle. Okay. I will explain these using the first principle. All these questions, although in the book it is not mentioned whether you have to do these by the first principle or directly. So I will explain you directly only. It is fx is equal to sin x into cos x, because in question it is not mentioned that we have to solve it using the first principle. So suppose it is sin x cos x, we will differentiate this using the first principle. So it will be f dash x is equal to fx plus h minus fx divided by h. This is the formula. So put fx plus h in this, put replace x by x plus h. It is sin x plus h cos x plus h minus sin x cos x. Now you multiplied by 2 and divided by 2 throughout. We have multiplied this by 2. We'll use simple trigonometry. This also by 2 and divided by 2. Now 2 sin a cos b is actually, this is 2 sin a cos b. The formula is 2 sin a cos b is, this is 2 sin a cos a, sorry, 2 sin a cos a, that is sin 2a. We'll use this formula. 2 sin a cos a, this is also sin 2x. So this is sine 2x plus h minus sine 2x. In this we will apply the formula sine c minus sine d, that is equal to 2 cos c plus d by 2, 2 cos c plus d divided by 2 sine c minus d by 2. This is the formula for twice sine a cos sine c minus sine d, that is 2 cos c plus d by 2 sine c minus d by 2. In this 2x is cancelled out by this 2x, it is sine 2h by 2, that is h only, and this 2 is cancelled out by this 2. So we are left with this sine h divided by h, that can be taken as 1. So it is limit h tends to 0 cos of 2x plus 1, limit h tends to 0 sin h by h. So sin h by h is 1, and in this you put h equal to 0. So this will become cos 2x. Second, you have to differentiate sec x. So f dash x, we know that it is fx plus h minus fx divided by h. Replace fx by sec x. So it is sec x plus h minus sec x divided by h. Convert sec into cos. It is 1 upon cos x plus h minus 1 upon cos x. Take cos x and cos x plus h as LCM. It is equal to cos x minus cos x plus h. Now apply the formula of cos c minus cos d equal to minus 2 sin c plus d by 2 sin c minus d by 2. So it is minus 2 sin c plus d by 2 x plus h. This is c and this is d. So c plus d by 2 sin c minus d by 2. So this thing will become 2x plus h by 2, and this thing is minus a sine minus h by 2. In denominator, it is you can take out this cos x because there is no h in this. As there is no h, we can take it out because if we will put limit h tends to 0, there is no role of this cos x. So it is 1 upon cos x, limit h tends to 0, 1 upon h. This is sine minus h by 2 can be written as minus sine h by 2. So this minus sign and this minus sign will become plus. So this is sine 2x plus h by 2, sine h by 2. We can write this h divided by 2 in the denominator of sine h by 2. Mean denominator of this sine h by 2, it will become h is already there and 1 2 is already there. So we can write it as sine h by 2 upon h by 2. This thing and this thing are same. So sine h by 2 upon h by 2, we will take this as one limit and we know it is equal to 1, and another limit is limit h tends to 0 sine 2x plus h by 2 upon cos x plus h. In this you put h tends to 0, put this is equal to 1, so it is 1 upon cos x into over here you will get it is sine x, put h equal to 0 divided by cos x. So it is sec x into tan x is the answer. Okay, if you are confused in this step, I can explain you again. Actually this will become plus because, and this is also become plus. Now what to do? In the denominator of this you need h by 2, make it as 1. So 1 h is already there, so I have taken this h over here, multiplied by 2 and divided by 2. So this 2 will be cancelled out by this 2. Now you are left with this much thing only. Sin 2x plus h by 2 sin h by 2 cos x plus h upon h by 2. So in this way you can get this thing. Now we'll discuss the next part. 5 sec x plus 4 cos x. So we know that f dash x is equal to limit h tends to 0, fx plus h minus fx divided by h. You can write limit h tends to 0, 5 of sec x plus h plus 4 cos x plus h minus 5 sec x into 4 cos x. This part you can take separately. 5 you can take common from this. Sec x plus h and sec x you can take separately. And from this you can take 4 as common. It is cos x plus h and cos x you can take separately. Convert this into cos. It will be 1 upon cos x plus h. Now actually we need not to do these two parts. This we have just completed in previous question. So you have to follow only those steps. So directly write it as sec x tan x. You see, This thing we have just done in this step. So you have to repeat all these steps till this. Sec x plus h, you have to solve this one particular part. So in this we have to repeat all those steps. So just do your previous question to solve this. And this also we have done in earlier one question. You see cos differentiation of cos x. This case, question number 10. So in this just you have to repeat second part of this question, and this is your question number 10. In this you can write it is sec x tan x, and this is minus sin x. So that would be the answer. Cosec x you have to differentiate, so it is limit s tends to 0 1 upon h cosec x plus h minus cosec x. Convert this into sine, it is 1 upon sin x plus h minus 1 upon sin x. You take sin x and sin x plus h as LCM. It will be sin x minus sin x plus h. So sin c minus sin d is actually 2 cos c minus 2 cos c plus d by 2 into sin c minus d by 2. So it is 2 cos c plus d by 2 and sin c minus d by 2. Over here it will be sin minus h by 2. Again we will do the same thing as we did in previous part. This h we will take in the denominator over here. We will multiply it by 2 and divide it by 2. So this 2 will cancel out this 2, and this negative sign will also come out because sin minus theta is sin theta. So in this way ultimately we'll get this thing. Minus cos 2x plus h by 2 sin h by 2 upon h by 2 divided by sin x plus h into sin x. Okay, first you will take this negative out. So this negative sign will become out. It will be minus 2 cos x plus h by 2. 2x plus h by 2. It will become sin h by 2. This h I will take it in the denominator of this. This term will remain as it is in the denominator of this. So to make it standard form, I will multiply it by 2 and divide it by 2. This 2 will be cancelled out by this 2. So we'll have sin h by 2 upon h by 2. In this way you can do it. This is one. Apply limit on all these things. This is one. In this you put h0. In this also you put h0. This sin x is as it is. So in this you will get it is minus cos of 2x by 2, that is minus cos x. Put h0. This is 1. In this also you put h equal to 0. So it is minus cos x in numerator and sin x into sin x in denominator. You can write minus cos upon sin as cot and 1 upon sin as cos x. That will be the differentiation of this. Fx is equal to 3 cot x plus 5 cosec x. So cot part we will do, cosec x part we have already done in the previous question, so I will not repeat it again. Cot part in this case we will do. Okay, so the cot part we will do, and cosec x we have done in the previous question, so we'll write directly the differentiation of the cosec x. So this cot part is 3 limit h tends to 0 cot of x plus h minus cot x, and cosec part is 5 limit h tends to 0 cosec x plus h minus cosec x. You need not to write this step also. The cot part we will solve only because cosec part we have solved in the previous question. So it is cos of x plus h upon sin x plus h minus cos x upon sin x. You can take sin x plus h into sin x as LCM. So it will be cos of x plus h into sin x minus cos x into sin x plus h upon this. And numerator, this is the formula of sin a minus b. So it is equal to sin of x minus x plus h. That would be minus sin h. This negative sign you can take common. It is minus sin h. So negative sign you can take common. It will be, this negative sign is here. So it will become sin h upon h divided by limit h tends to 0 sin x into sin x plus h. This is 1. Minus sign is already there. It is 1 upon sin x into 1 upon sin x. So it is minus 1 upon sin x square x. that is cos square x. So the derivative of this part is cosec square x. So this is 3 cosec square x. This we have already done, minus cot x, cosec x. So put the value of this from fourth part. It is again repeated, you need not to do it. Because in previous question we have already done the derivative of cosec x. So directly put the answer. Similarly, question number 6, now you need not to do all these things. 5 sin x minus 6 of cos x plus 7. 5 sin x minus 6 cos x plus 7. So you have to calculate limit s tends to 0. Derivative of sin x, 5 into derivative of sin x minus 6 into derivative of cos x by first principle. And we know that 7 is a constant, so its derivative will be 0. 7 is constant, so its derivative will be 0. So we are not writing this. You will write, then also this 7 will be cancelled out with this 7. In case of 7, fx plus h is 7, fx is also 7, so it is 7 minus 7, that is equal to 0. Or suppose we put fx plus h, in whole this we replace x by x plus h, you are going to get this thing. And then minus fx, same thing, divided by h you will write. So now this 7 is cancelled out with 7. Keep the terms of sines separately, terms of cos separately. We'll differentiate this sin of x plus h minus sin x. We'll differentiate this. This part we have done in question number 10. This part we'll do in this question. This is sin c minus sin d, that is equal to 2 cos c plus d by 2 sin c minus d by 2. This one part I will directly write, it is minus sin x. From question number 10, you can copy it. It is the same thing which we have done in the question number 10. In this part now, it is sin x plus h minus x by 2. So x is considered by h, it is sin h by 2. This one h is already there. So you put this h in denominator, you multiply it by 2 and divide it by 2. When we will multiply it by 2, that 2 will cancel out this 2. So it will be cos of 2x plus h by 2 into sin h by 2 divided by h by 2. Or it is already h by 2 is there in denominator. You see h upon in numerator it is 2. So if I take this 2 in the denominator, it will become h by 2. Now limit h tends to 0, sin h by 2 upon h by 2, that is equal to 1. And in this you put h equal to 0. So it will become cos x only. Cos 2x by 2, that is cos x. Cos x. So it is 5 cos x. And derivative of this thing we already know. This we have solved in question number 10. So it is minus sin x. So minus 6 is already there. So it will become plus 6 sin x. Question number 7th. First principle method. So again it is the derivative of fx plus h minus fx upon h, you can write. Separate the term of tan. Separate the terms of sec. In 10 you can take this 2 outside, and in this you can take this 7 outside. This differentiation we have already done in the second part of this question. This limit we have solved, it is sec x tan x. So I will put it as sec x tan x. I am not solving this. Tan we have not done, so I will differentiate this tan. So tan can be written as sin x plus h upon cos x plus h minus sin x upon cos x. Take cos x plus h and cos x as LCM. It will be sin x plus h into cos x minus sin x into cos x plus h divided by cos x into cos x plus h. This part I am not solving. In numerator it is sin a minus b formula, so it is sin x plus h minus x, sin a cos b minus cos s sin b, cos s sin b. So that is sin a minus b. A is x plus h, b is x. So it is sin h only. 1h is already there in denominator, so it will become sin h by h. 1 upon cos x into cos x plus h. This will become 1, and in this you put h equal to 0. So the final answer will be of this part, it is 1 upon cos x into cos x, 1 upon cos square x. That will be sec square x. So the derivative of this is sec square x. So it is 2 sec square x, and this we already know, it is sec x into tan x. So in this way we can get the answer of this question also. So now this exercise over. I hope you will be able to do these questions. In these some differences in the repeated, so you need not to do time and again. Like sec x you have done in first part. If it is there in any other part, you can directly use that. Like cos x we have done in question number 10. So you need not to do the differences of cos x time and again. We can use only that one particular differences, and if it come in exam then you can do it because you have done this in the question number 10. So I hope now you will be able to do all the questions of 13.2 exercise. Thank you.